This chapter has a few parts to it. This is the easy part, so you should have a nice smooth ride here today and tomorrow while we work on just this topic. It gets harder when we get to the inequality versions of absolute values. That's a lot harder on the brain, but equations are pretty cut and dry. So here in about 10 or 15 minutes, you should totally understand the gist, how to do it. So let's get to it. I have a ton of examples. You know how I teach, just examples, and I try to cover all the bases. So my first row of examples, I just have some really simple equations. I assume by this point in your life that you know what the absolute value is, but I would be remiss to start an entire chapter on this and not talk about it. So when I say the absolute value of a number, what am I referring to?
How far is away from zero?
That's a perfect definition of absolute value. How far a number is away from zero. So if I said to you, I need you to solve this equation, what I'm saying to you is find all values of x that you'd have to walk 10 steps away from zero to get to. That's what it means. Literally, find all numbers whose distance from zero is 10. How many numbers are there that are 10 steps away from zero? There are two of them. What are their names? Good. So we solve a simple equation like this by just saying that x can either equal 10 or x can equal -10. So oftentimes, the vast majority of the time, absolute value equations are going to have two solutions because there are two things that can make the stuff inside the absolute value what we want it to be. Okay. What about an equation like this one? How many numbers are there that are 0 steps away from zero? One is perfect. Yes, there is one number that is 0 steps away from zero, and his name is 0. The only number that we can say it takes 0 steps to get to is 0, because you literally don't go anywhere. So that is going to be the only scenario with absolute value equations in which you get one solution. It's when it's that perfect centered 0, right? Any other time you're looking for go to the left, go to the right, and that's why you get two solutions. And then the final scenario is something like this. How many solutions does this have? It does not. Wow, what a great way to start the morning. 0, because you can't measure distance in a negative. Distances, by definition, are non-negative values. I can ask you to walk 0 steps and you could just stand still. I could ask you to walk 4 steps, 12 steps, but I cannot ask you to walk negative quantity of something. So if you truly understand what absolute value is about, you understand that there are no numbers that have a negative distance from 0. Distances, Kaysen said it perfect, distances cannot be negative. Therefore, if you ever find yourself looking at an absolute value equal to a negative number, then you can say that there is no solution. And you can write out no solution if you would like to. You can also use the circle with the slash through it. That notation, bless you, that notation is for what we call the empty set. So the set of solutions here is empty. It has no numbers in it. So that's the basics. Top row was just to get you familiarized. Any questions just on that? So in the second row of our examples, we're going to start throwing some cream filling now into the absolute value. So what if I said to you, the absolute value of x plus 3 has got to equal 7? Understand something now. I'm not necessarily looking for numbers whose distance away from 0 is 7. I'm looking for numbers that if you add 3 to them, then the answer to that math problem has a distance of 7. So, yes, sir? 4. Good job, Kane. Yes, 4. 4. Woof. 4 definitely works, doesn't it? But there's another number that works as well. Do you know what it is? Kane?
Negative.
-10 also works. Good. So for those of us that don't want to sit here and do mental math, there's a process to this, and you better get used to what we're about to do in this problem. Get used to the word split. We're going to probably, at least I know I am, and you probably will too, say the word split dozens, if not hundreds of times. And so the way we solve an absolute value equation is to split it into two. I didn't feel like showing any work was necessary on the first row of problems because those are stupid. Like, give me a break, easy peasy. But here it gets a little harder for some of us to conceptualize what is x. So what we do is we split it into two separated equations. And we create two situations that we want to be true. And one of the situations, whatever x is, if you add 3 to it, it could equal 7. We're trying to make the cream filling inside the absolute value equal something that will satisfy the equation. And the other scenario is I could make the cream filling x plus 3 also equal -7. These are the two scenarios that have to be true. What's inside, I'll color it for you. What's in the yellow has got to either equal 7 or -7. So I've simply written two equations that force that hand. I say, I need this to be true. And in math, if you want something to be true, you write an equation and then solve it. And then, problem solved. So we're going to solve each of these little rinky-dink like sixth grade equations. On this first one, if we subtract 3 from both sides, we get the first answer that Kane brought up, 4. Right? And that was the obvious one. We can all figure out that 4 plus 3 is 7. And if what's inside the absolute value equals 7, then we're good. The other one, if we subtract 3 from both sides, -7 minus 3 is the other one that Kane sort of delayed reaction gave us there, -10. So these are the two solutions to the equation. We split the equation in two and then solve the resulting equations. Okay. Where people start to fail on this is they say, oh, the answers are 7 and -7. And it's like, no, that's not true. We're building towards a 7 and a -7, but they're not the answers. Right? They're just kind of a step along the way. Let's try that again. So the absolute value of -3x, we want to equal 15. So we're going to go to Splitsville here. So we're going to split. We're going to split. What's one of the equations that we're going to write? I don't want a solution, okay, please. So just an equation that I could write?
-3x equals 8.
That is a fact. Whatever's inside the absolute value, maybe it equals 15. What's the other equation that we want to write? Same thing, but with a -15. And again, if you're lost right now in the chaos, don't overthink this. We're just trying to make what's inside the absolute value bars equal one of two numbers. So that's where the algebra comes in, is we just write the equations and then solve what we get. And then on both of them, usually what you're going to find is the end of this is pretty, if you struggled with equations in Algebra 1, you'll struggle here too. But the equations that we get are not difficult. So on this one, if we divide by -3, we can figure out that x equals -5. And on the other one, if we divide by -3, we figure out that x could also equal +5. So to be perfectly clear, when we talk about solutions, the things in the purple boxes are the solutions. Everything prior to that is just the work that we do to get to the solutions. So far, so good. Okay. What if we had like the absolute value of x minus 6 equals -1? What would we get here? I wish that were true. You could sit here for 100 hours. Not that you would. That's what a crazy person would do. But you could sit here for 100 hours and keep putting numbers in place of x. You could do anything that you think you want. Put anything you want in there right now. Like you're thinking 5 is probably pretty money, huh? Put in 5. What's 5 minus 6? -1. Jackpot. But the trouble is these guys. The absolute value dominates and says, do whatever you want. But when I take the absolute value of -1, what is the absolute value of -1? It is 1. You could sit here for 100, 200, 300 years, and you're never going to find a value for X that when you do the math, that the yellow bars then produce, poof, I'm going to pop out a -1. The answer to this problem is that there is no answer to this problem. When you get down to the end, which this will kind of become the end, you'll see, where the absolute value is all by itself and you're ready to roll. If the number on the other side says negative, stop. No solution. Okay. There are no equations to create there. It's a situation that just isn't doable. So don't assume on every problem that we're going to go to Splitsville and write 2 equations. You got to stop and think, is it even possible? How about this one? Is this one doable? Oh yeah, for sure. Because we got the absolute value equals. We always want to look at that other side. If it's a positive, we're like green light, baby. Let's go. So what is one of the equations that I'll write? That's a possibility. Okay. Or the other equation is stuff inside the absolute value might equal what? Yeah, those are both realistic scenarios. And then we just have to do the algebra. So these are 2-step equations, unless you're, really good at mentally solving and moving things around. But conventionally, what people would do to solve is they would add 4 to both sides. So like if I added 4 to both sides on this one, it would say -x equals 8 plus 4, 12. But see, we're not done, right? How do we finish an equation that has a negative like that? You divide by negative or -1 or whatever you want to call it, as long as you get rid of the negative. Essentially, you're pawning the negative off on the other side. Like you're saying, okay, X, I need you to be positive. Therefore, 12, I need you to be negative. Okay. Let's go to the other side. So the algebra is always the same that you do, by the way. You figured that out. The equations are similar in that the steps you do will always be the same. The answers that you get will never be the same. Okay. So again, if we add 4 to both sides, we get -x equals -8 plus 4, which is -4. And then again, pawn off the negative. So the X becomes positive. And then the -4 is like, well, I guess then I'll become positive too. At the ending step with a case like that, you just switch everybody. And it's always a good idea to check. I mean, rarely like 10% of kids actually go back and check their answers. But if you take these numbers, like if you take that green boxed number and you put it right there, you can verify that it's legit. Like -4 minus -12, -4, oh, plus 12, 8. It works. So you can always, vet your answers before you turn in a quiz or something like that, or before you, if we were doing Delta, like if you hit submit, and again, you're always welcome just to plug it in and do the math. So that's always, with equations, that's always true. Any questions so far? Okay. So now begins the second part or the third part of this, and this is where we start to really say the words that are going to kind of become our battle cry here. So let me get an example up here, and then I'll show you what I mean. The absolute value of X minus 10 plus 6 equals 14. There are 6 words that will pretty much carry you through this entire next few weeks. Not really, but they'll be a good starting point. Like you remember with factoring how GCF kind of became the battle cry? Like without that, you could not pass that quiz. Like no way. With this, the 6 words are get the absolute value by itself. Knowing that is going to get you through. All the stuff we've talked about so far about writing equations and Splitsville and making decisions about is it possible or not, none of that matters until you have the absolute value by itself. So this thing, this yellow thing is locked in place. And who do we have to move away? The plus 6 has to go. Okay, we're not going anywhere until we isolate the yellow. So if I subtract 6 from both sides, then I get the absolute value of X minus 10 equals good. And now we're right back to where we were before. So what are the 2 equations that we'd write on this one? X minus 10 can equal -8, or X minus 10 can equal +8. Obviously, the order you do those in makes no difference, right? And these are both real quick solvers. If I add 10 on the first one, I get 2. And if I add 10 on the second one, I get 18. And again, feel free to vet them just for shiggles. Go plug it back in and say, hey, it actually works. Legit. Neat. Okay. To get the absolute value by itself, sometimes you have to do other things than just adding or subtracting. For example, this. Any thoughts on this problem, like initially when you first see it?
I'm by about 3.
Right. And if your thought, thank you for not 3, but -3. If your thought was that there's no solution, I'm proud of you because you're listening well, because you're like, hey, that's a -21. But we're not at a point in this problem yet where we can pass judgment on that because the absolute value is not by itself. So any considerations like that, they're not even valid until we are ready to make that choice. And that choice cannot be made until, again, yellow guy is by himself. And so, like Kane said, let's divide. Anytime there's something stuck to something that I want to be by itself, I know, I've been in math classes long enough, I know to divide. So if I divide both sides by -3, now the yellow thing will be by itself. I'm not going to make it yellow anymore, but it'll be ready to rock and roll. The absolute value equals what? +7. So what initially might have looked like a no solution situation, we realize, oh, it kind of righted itself. Like when I divided away the negative, all's good. So this is another situation in which I would go to Splitsville. So my two equations are cream filling equals 7, or maybe cream filling equals -7. I always think of these as Oreos, like a cookie with that good stuff sandwiched in there. So. And these are two-step equations. On this first red equation, if I add 5, what do I get? I'm gonna go with 12.
Oh.
Yeah. I'm just thinking crazy, 7 plus 5. I'm just going to try 12 out, see how it goes. And then if we divide 12 by 2, what do we get? Ah, nice. There's one of our solutions. So on the next one, if I add 5 to both sides, what do I get? That is not a 2. That is a -2. -7 plus 5 is -2, right? And then if I divide both sides by 2, I figure out that x might just equal -1. And as always, feel free to plug those back in. Okay. And the last one in this, can I scroll? Okay. The last one in this section, and then we'll get to the ending ones. They don't really ever get any really harder than this necessarily. um, what do we do? Good job. So a situation that looks okay is about to not be okay, right? So again, we make our decision once once the initial work is done. Once I divide away the -4, then I'm left with the absolute value by itself, just like I always need it to be. And then I realize, oh crap, a +12 divided by a -4 equals -3. Don't fall for it, right? Don't just robotically go into split mode here. You got to look at this and say, hey, I know that absolute value can never produce a negative, therefore there is no solution. We don't make that decision though until the end. Okay, feeling good so far? I have 3 more examples, and all they are is just basically a hybrid of everything that we've learned so far. So this, for example, -6 times the absolute value of 3x plus 1 minus 4 equals -16. Don't even think right now, is there no solution or is it Splitsville? Like, it's premature. So let's just do what we know to do. You do enough algebra in your life and you just develop senses for what to do. Like you've never solved absolute value equations before, probably, but you get it. Like you get how algebra works. If you want to get the yellow thing by itself, what do you know is the first step? I really thought you would not say that. I really did not think that. Let me give you a similar situation over here. If I gave you negative 6m minus 4 equals negative 16, what would you do? You would add 4. And I know a couple of you said that, but there were also a couple of you that said to divide, and that kind of chilled me to my bone a little bit. This is not the time for division. You know in algebra that we add or subtract away extraneous terms first, and then we divide. You know that. Don't forget that just because we're doing something that is new. So do not divide. Add 4 to both sides first. That's what the algebra says to do. I mean, algebra rarely changes. Like the steps that we do are pretty repetitive. What's negative 16 plus 4? Nice. And again, we're not ready to look at it and say, ooh, it's negative. There's no solution. Because if we divide both sides by negative 6, then we realize, hey, everything turned out okay. I have the absolute value of 3x plus 1 equals 2, and I'm ready to proceed. So you just let that take care of itself. Do the algebra, and then whatever happens, happens. What are the 2 equations that we'll write? Or
3x plus 1 equals 2.
both perfect scenarios. Solve these and you've got your solutions. On the one on the left, the first one, if I subtract 1 from both sides, what do I get? We get 3x equals negative 3. And then if we divide both sides by 3, we get x equals negative 1. On the one on the right, if I subtract 1 from both sides, what do I get? 1. And again, I'm not interested in your final answers, right? Like I need equations. 3x equals, I think you were answering you said 2 minus 1. So that was not bad. So 2 minus 1 is 1. Now, if we divide both sides by 3, what do we get? We get 1/3. And those are your solutions. As always, feel free, plug them back in, give them a check. Okay. Still feeling good? All right, couple more. Next one, negative 10 minus 2 times the absolute value of negative 2x plus 9 equals negative 20. What do we do first?
Negative 10 minus 2.
No. Again, I have what I do in a case like this is I have to go back to something that I know that I can say I know I taught you because you were my students. And so I'm going to replace this with the letter M, just to show you that you know not to say things like to do negative 10. You just sometimes forget that you know. Here's the same equation right here. Negative 10 minus 2m equals negative 20. Hanging out with me, you've solved equations just like this hundreds of times. What would you do first? You would add 10. So don't give me some line about, hey, look, I'm going to just bust up the order of operations and add these numbers together. You know better than that. Don't do that. That's why that example made it onto the note card this morning, okay? So what we're going to do first is we're going to add 10 to both sides. And if you do that, you're left with the negative 2. He's still attached, waiting for us to break him off. And then on the right-hand side, what's negative 20 plus 10? 80. Nice. And now we divide by negative 2. Like you go break in the order of operations. Like you know how to solve equations. If you divide both sides by negative 2, you get the absolute value of blah, blah, blah equals 5. And this is the crossroads. For the next couple of weeks, we're going to do equations and inequalities. And this is where every problem arrives at, where we make a choice. And the choices are, with equations, the choices are simple. Either I stop and say no solution, or I proceed into Splitsville. This is a proceed, because 5 is doable, huh? So our equations are negative 2x plus 9. Maybe it equals 5. Or negative 2x plus 9, maybe you equal negative 5. Don't know. I'm just going to cover my bases and solve them both. If you subtract 9 on this one, what do you get? Negative 2x equals negative 4. And if we divide both sides by negative 2, we get x equals, there we go. That's a solution. On the other side, if we subtract 9, what do we get? Thank you for saying the whole equation. Negative 2x equals negative 14. Negative 5 minus 9. I hope that's what it equals, or I've been messing that up for a long time, right? If we divide both sides by negative 2, then x could equal maybe 7. One more. Any questions so far? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that's 12 examples. I'd have to go back and watch the video and recount them, but I think that's 12 examples down, 1 to go. I did go a little rogue there in the middle. I might have, I don't know. Last one. Oops, that's not supposed to have an X on it, so get rid of that if you have it. Always remember to make your absolute value bars slightly taller than the numbers and the letters so they don't look like ones. Okay. I mean, I don't personally care, but it's pretty easy to mess up in the middle of a problem. If you have like the absolute value of 1 and then you're lazy, that could really quick look like an 11. So just be careful. Step 1. Nice. Good. Let's subtract 15 from both sides because that's a positive 15. So we get the negative of the absolute value of, dang, dude, learn how to write. Negative 6 minus 4x equals, what's 3 minus 15? What are you thinking? No solution? Of course, we got to divide away the negative, right? We are not at the crossroads yet where we make a decision. The absolute value is not yet alone. If we divide both sides by negative 1, then we get absolute value of negative 6 minus 4x equals. And once again, we realize once all the smoke clears, we go, I can proceed. So I have 2 equations, negative 6 minus 4x, maybe u equal 12. Or negative 6 minus 4x, maybe you equal negative 12. Let's go find out. I should phrase my question better so that I get the whole thing. What will the next equation say if I add 6 to both sides? And then we divide by negative 4. And it's okay. We're not going to panic just because there's a little fraction here, right? No big deal. We're going to get x equals negative 9 halves. It's negative, of course, and 18 divided by 4 is just 9 over 2. On the other one, if I add 6 to both sides, what do I get? Negative 4x equals negative 6. Divide both sides by negative 4 and x equals 3 over 2. 3/2. Any questions? I think I covered all the bases. I tried to study it and go, what could I possibly include here? I think I got it. Knowing me, there'll be a question. Someone will go, hey, we didn't talk about this. That's my bad. So I'll keep this recording going. But your assignment is on Canvas. It's just one of those clickable PDFs. You know the drill. Bring it up. Do it on your own dang paper.